So my name is Marina, and our group is doing Station 2, equivalent fractions with multiple representations. So the question that we have, or the prompt, is generate as many ways as you can to demonstrate how to create equivalent fractions to 2/3. Use as many varied strategies as possible. So we're going to show you different examples of ways to represent equivalent fractions.
Hi, I'm Lindsay. And I'm Maricela. And equivalent fractions are different fractions that name the same number. To create equivalent fractions, there are many different methods you can use, such as multiplying the numerator and denominator, dividing the numerator and denominator, drawing diagrams, and using a number line. So here's a fraction 2/3, and we're going to use the method of multiplying by the same number to each the denominator and the numerator. So 2 times 5 is 10, and then 3 times 5 is 15. And we're going to do the same, multiply by 5, and so it equals 50 over 75. Now we're going to get 50 divided by 75, over, and we're going to divide by 5 to each. So 50 divided by 5 is 10, and 75 divided by 5 is 15. Now we're going to divide again by 5 to the numerator and denominator, and it's going to be 10 divided by 5 is 2, and 15 divided by 5 is 3. And so here you can say that these are equivalent to both. Hi, okay, so I'm going to talk about equivalent fractions using diagrams. So imagine you have 2 cakes. We're going to use 2/3 to represent the cakes. So this is 1 cake, and we're going to divide it into 3 pieces. So 2/3 of this cake, you could shade in 2 of the 3 slices. Now to represent an equivalent fraction, you can multiply 2 over 3 by 3 to get 6/9. And we can show the same cake but we'll divide it into 9 parts instead of 3. And instead of shading 2 slices, we'll shade in 6.
Oh my God.
So you can see, even though here you have 6 out of the 9 shaded in, and here you have 2 out of the 3 shaded in, they're the same amount of cake that has been shaded. So this just shows how 2/3 is the same as 6/9. Okay, so now we're going to do another diagram. So imagine you have 2 blocks. And here's 1 block, so we're going to break it up into thirds. And you want to shade in 2/3 of this block. So you'll be shading in 2 out of the 3 pieces. Now we're going to take the same size block but we're going to represent 6/9. And we'll do that by shading in 6 out of the 9 pieces. So you can see that the same amount has been shaded, and you can also see that here you have 1/3 left. And here you also have 1/3 left over. And you know this because you have 3
It's the white, round,
out of the 9 pieces
rounded
left.
by Baker.
And 3/9 is the same as 1/3 left over. So because you have 1/3 left over in both blocks, the situation shows how 2/3 is equivalent to 6/9.
Okay, so the third way that we're going to show an equivalent fraction of 2/3 is the number line. So if we draw our first number line, we can put the first, or the end of it at 0, and then all the way to 1. So in between 0 and 1, we're going to break it up into thirds. So it'll be, this will be 1/3, 2/3, and then 1 is equal to 3/3. So if 2/3 is right here on the number line, and we're trying to show that 2/3 has an equivalent fraction of 4/6. So if we draw a second number line with the same, with 0 at the front and 1 on the other side, now we're going to break it up into sixths. So we know that it can be broken up into 6 because if you multiply 2/3 by 2, you'll get 4/6. So we're going to show that 4/6 is equivalent to 2/3. So if we break it up into 6, this will be 1/6, 2/6, 3/6, 4/6, and 5/6. So now we have 2/3 will be equal to 4/6. And we can show that by doing the first example that we showed, which is this. If you multiply 2 by 2, you'll get 4, and then 3 by 2, and you'll get 6. So, which is 4/6, and we mark down the number line. So if you draw the same size number lines and you break them up, you can tell that these are equivalent fractions, and it'll help you show that because they're lined up. So we know that it's taking up 2/3 of the number line, and then it's taking up 4/6 of the number line. Okay, so now that we've shown you different ways to create equivalent fractions, we have a challenge problem. So the problem says, convince a student that 16/20 is equal to 12/15 in as many ways as possible. So we're basically trying to show them that this equals each other, even though you can't directly get 12/15 from 16/20. So there's going to be multiple ways that you can do that, and you can use the same strategies that we used at the beginning. So you can use diagrams, number lines, and you can multiply and divide common multiples of the numbers to either reduce it to the same fraction or make it bigger and make it equal the same fraction.
Okay, so to get the LCM of 20, get the multiple, so it's 4 and 5. And then 2 times 2 is 4. And then the LCM of 15 is 3 and 5. And so you add 3 times 5 times 2 squared, which equals 60. So that's the common denominator. So to get 60, you multiply 20 by 3, and so you multiply 3 times 16 in the numerator, and it becomes 48. $60 as a denominator, and then to get 60 from 15, you times it by 2, And so you get 15 times 2 is 30. And then 12 times 2 is 24. And you do 30 times 2 is 60. And then 24 times 2 is 48. So the equivalent fraction of both 16 over 20 and 12 over 15 is 48 over 60. Okay. Now if you work backwards, and divide both by 3, you got 16 over 20. And if you do the same and divide both by 4, you get 12 over 15.
Okay, so now we're going to use a diagram to do the challenge problem. Each of these bars equals one whole, but they're all cut up into different sized pieces. So this one right here has 15 pieces, and we're going to shade in 12 out of the 15 pieces. This one right here is cut up into 20 pieces, and we're going to shade in 16 out of the 20 pieces. And this last bar here is cut up into 5 pieces, and we're going to shade in 4 out of the 5 pieces. Now as you can see, they're all cut up into different sized pieces, but they're all left with the same amount left in the end. So you have this amount left, and that's all the same even though they're cut up into different sizes. They all take up the same amount of space. Okay, so the reason why we show 4/5 here is because 12/15 and 16/20 both reduce to 4/5 in their simplest form. So this shows how these can both be reduced to equal the same amount, which is shown here. And if you want to double check your work, you can do so by adding the remaining amount left to show that they're all the same. So here you have 1 out of the 5 squares left, so you have 1/5 remaining. And here you have 1, 2, 3 out of the 15 squares remaining, which also reduces to 1/5. And this one you have 1, 2, 3, 4 out of the 20 squares remaining, which also reduces to 1/5. And because they all have 1/5 left, you know that they're all equivalent.
Okay, so the last way that we can show that 16/20 equals 12/15 is using number lines again. So if you draw the number line, this whole number line is 1. So 0 will start over here, and 1 will be over here. So we're going to break this one up into 20ths. So the middle would be 10 20ths, and then there would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So all of these are out of 20ths. So 1 equals 20 20ths. So we're trying to show 16/20. So if you mark 16 on the number line, it would be 11, 12, 13, 14, 15, 16. 16/20 would be right here. So now we're going to show 12/15 on a different number line. So 0 is over here and 1 is over here. So we're going to have 15, they'll be out of 15s. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then this is 15. So we're going to mark 12 15s on the number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 15s. So you can already see now that they basically line up, which you can tell that they take up the same amount of the number line because they're both out of 1. So like in the last example, we're going to show you that they also equal 4/5. So we're going to draw another number line, and we're going to make them out of fifths. So it'll be 1, 2, 3, 4, 5. So this one is equal to 4/5, and that would be right here. And the reason why we're doing 4/5 is because the reduced number, the most simplified number you can get out of 12 15ths is 4/5, and 16 20ths is 4/5. So even though you can't get 12 15ths directly from 16 20ths, we know that they're equal because the most simplified number is both 4/5.
Alright, this was Station 2, Equivalent Fractions with Multiple Representations. So now I hope you guys will be able to find equivalent fractions using many different methods, and hope this video was helpful. Thank you for watching.